Hello friends, in this session I am going to discuss the sliding window protocol which comes under the flow control techniques of data link layer. So in the previous session we discussed some of the flow control techniques of data link layer. We also discussed the brief idea about data link layer and its functions. So this video is just in continuation to those concepts. In case you want to revise them, review them, you can please view the previous sessions. And I'm going to clarify that I'm just going to give a brief idea of this protocol because in GATE or in most of the competitive exams, they entirely check your understanding about the concept and if you can apply it in finding out and solving some of the numericals. So the approach for discussing the concepts by me is also the same. So I just discuss the brief idea and then I give you the numerical part of it. I discuss the formulation of various concepts like channel utilization, throughput, etc. and then we apply it together in the numerical part. So let's start with this concept as well. So the brief idea of sliding window protocol. What is a sliding window protocol situation? What does happen in it? That we are going to discuss first. So in this, what happens is the sender has a window placed over the buffer. As you all know that buffer on the sender side keeps storing the frames prepared by the sender. So over here, what happens is there is an additional window which is present on a subset of frames present in the buffer. So it does not enclose all the frames present in the buffer. It is placed on the subset, right? Subset of the total frames present in the buffer. And the number of frames which can be present in the window is equals to the size of window. So if the size of the window is 4, there can only be 4 frames present within this window. Now the sender over here, what is the benefit of sliding window protocol is that the sender can send all the frames present in the window one by one without expecting any acknowledgement. So the sender does not have to wait for an acknowledgement from the receiver end till it has sent all the frames present in the window. So this is an advantage. It basically reduces the delay or you can say the waiting time for which the sender had to wait before sending the next frame. So next, frames are labeled depending upon the bits used for the frame header. So since there are some frames stored in the window, they'll also be labeled, right? The frames will also have some frame numbers. So frames are labeled depending upon the bits used in the frame header. For example, for instance, if there are 2 bits which are used from the frame number, that means there will be 4 combinations. So the frames can be numbered as 0, 1, 2, 3. So the scenario will be something like this. We have the sender over here, we have the receiver, we have the window over here, we have the frames labeled as 0, 1, 2, 3. So this is the first frame to be sent over here. So now what is the difference in this scenario? The difference is that the sender can send all the frames present in this window without waiting for the acknowledgement from the receiver. Another thing over here is now that if we consider the active time of the sender, now it has increased. Why? Because first it was just sending a single frame, so the active time was only to prepare, the time needed to prepare that frame, which was TT, right? Transmission time, 1 unit of transmission time. But now over here it is sending 4 frames. So the transmission time will become 4 times. So the active time is equals to 4 multiplied by TT. So in general, if the window size would have been W, if we represent W as the size of sender window, then the active time would have become active time is equals to W into TT. So finally, if we just check the channel utilization formula, we'll replace TT with W into TT, right? And the throughput is what? The throughput is W into F. So for the similar explanation, this will be W into F. So the rest of the part of the formula remains the same. So channel utilization becomes this and throughput becomes this. So this these two formulas we are going to use in our numericals. Now another important thing over here is the acknowledgement sending methods. In this case, there are two acknowledgement sending methods. The first one is that the receiver can send acknowledgement for every frame it receives. Right? Receiver sends the acknowledgement for every frame it receives. And the second one is the receiver sends a cumulative acknowledgement. Cumulative acknowledgement. By cumulative acknowledgement I mean it sends an acknowledgement for multiple frames. So it sends a combined acknowledgement for multiple frames. It sends the acknowledgement for all the received frames belonging to the same window combinedly. Right? Sorry. So this there are two basic acknowledgement methods over here, and the main advantage over here is what? That the delay reduces, because now the sender does not have to wait for the receiver to send the acknowledgement before sending the next frame. So it can send multiple frames before waiting for an acknowledgement. So that's all for this session of data link layer sliding window protocol. I'm going to see you all with some more concepts in the next session. Till then, stay tuned and happy learning. Thank you.